In this video, we'll start modeling stairs from the very basics. We'll go through the core design principles and then move on to simple and practical modeling methods. So if you want to learn how to design stairs in a clear, professional, and structured way, stay with me. Hi, I'm Hussein, and welcome to my YouTube channel. I'm really happy to have you back here with me. Today, in this video, we're going to take a practical and in-depth look at stair modeling. As you probably know, stairs are one of the most important elements in architectural design. When they're not modeled properly, they can create real problems in terms of comfort, usability, and even safety. In this session, we'll explore several common types of stairs, and for each one, we'll build a simple example step by step. This way, the concepts become much clearer and easier to understand. But before we jump into modeling, there's one important topic we need to cover first: stair design standards. Professional and accurate modeling starts with understanding these standards. Without following them, a stair may look good visually, but it can still cause serious issues in terms of safety and everyday use. Stair design standards are exactly what help you create stairs that are not only visually appealing, but also safe and comfortable to use. When these standards are properly followed, they ensure that your design truly responds to real user needs and performs reliably, even in critical or emergency situations. Our goal is to help you apply these standards naturally while modeling stairs, so that the final result is strong both technically and aesthetically. This approach allows you to create designs that prioritize safety and user comfort without sacrificing visual quality. Now that we've covered this introduction, let's move into the details and take a closer look at the Neufert standards. Neufert is one of the most well-known and reliable references for stair design, helping you control key parameters such as width, riser height, slope, and landing dimensions. These guidelines are especially important for escape stairs and stairs used in emergency conditions, where safety and ease of movement are absolutely critical. Minimum allowable width of escape stairs. According to Neufert standards, the minimum useful width for escape stairs should be 105 centimeters. For public or residential buildings with more than 2 units, this width increases to 120 centimeters, and in special cases such as hospitals, it can even go up to 200 centimeters. This width is set to ensure that in emergency situations, people can pass through the stairs quickly and easily, preventing congestion. If the width of the stairs is less than this value, the evacuation process might not be carried out properly in critical conditions, endangering the safety of individuals. Standard stair landing dimensions. Landings are places where people can briefly rest or change their direction. According to Neufert, the size of the landing must be at least equal to the width of the stairs. For example, if the stair width is 120 centimeters, the landing should be at least the same width. This space should be level or have a maximum slope of 1/12 and should be free of obstacles. This dimension helps ensure that people can comfortably change direction or rest when going up or down the stairs without any issues. Standard tread dimensions. Stair treads should be designed to ensure comfort when using them. According to Neufert standards, the tread width should be at least 24 centimeters, but for general comfort, 29 centimeters is recommended, and for people with disabilities or the elderly, 25 centimeters. This dimension ensures that the foot fits comfortably on the tread and prevents slipping. If the treads are too narrow or too wide, it could lead to issues while moving and reduce overall comfort. Standard stair height. The height of the stairs, or the rise, should be a maximum of 19 centimeters, but for general comfort and for people with disabilities, 17 centimeters is recommended. This dimension ensures that movement is easier and more natural for individuals. When the stair height exceeds this value, it could make climbing the stairs more difficult, and people may feel more fatigued. On the other hand, if the height is less than 10 centimeters, it could disrupt the natural comfort of the body, and the person may feel a lack of support. Maximum allowable stair slope. The slope of the stairs should be adjusted in such a way that it doesn't put excessive pressure on the legs, ensuring that movement on the stairs is comfortable and safe. According to Neufert standards, the maximum slope for stairs is 40 degrees, but the preferred range is between 30 and 35 degrees for greater comfort. This slope allows individuals to move up and down the stairs without experiencing excessive strain. Steeper slopes can put a lot of pressure on the legs and make it difficult to navigate the stairs. Adhering to these standards not only helps ensure the safety and comfort of stair users, but also allows designers to create interior and exterior spaces with greater precision. By following these principles, you can design stairs that guarantee user safety in emergency situations. Now that we've covered these important details, let's dive into the world of stair modeling. With all this information in mind, let's start designing and modeling stairs that are not only aesthetically pleasing, but also follow safety standards perfectly. Are you ready? Let's get started. Now, we're ready to start modeling. The first example we'll look at is the common escape stairs, which are widely used and very popular. In this video, I'll model the stairs in two different ways, one as a concrete solid and the other as a metal structure. Let's begin with the concrete solid method. Before we start modeling, we need to make sure everything is set up correctly. The first thing we'll do is set the units to centimeters. This is crucial because it ensures we have precise scale and measurements for the modeling process. Next, we'll import the stair plan from AutoCAD. I'll leave a link to the plan in the video description so you can download and use it. We'll create a new layer named AutoCAD and move all the layers of the plan under this layer as sublayers. Then, we'll lock the layers to prevent any accidental changes. For the modeling process, we'll create a new layer named 3D. All the modeling will be done in this layer, and any related sublayers will be placed under it. After the initial setup, we move on to modeling the wall. We create a new sublayer called Wall and use the polyline command to draw a closed line for the wall. Since the map layer is locked, this makes the process much easier, and with snapping, the lines are drawn more accurately. Now, we'll extrude this line to a height of 310 centimeters using the extrude command. For the section above the door, I'll draw a rectangle and set its height to 210 centimeters, then extrude the rest of the wall to its full height. Finally, I'll select both the wall and the door section and use the Boolean union command to merge all the parts into a single unified wall. With the wall in place, we move on to modeling the stairs. We create a new sublayer called Stairs, and, using the locked plan, draw a rectangle for one of the steps, setting its height to 18 centimeters. To create rhythm and proportion, I make a copy of the same step, and by holding Ctrl and Shift, I select the edges. Then, I use the Move command to adjust the shape, creating a good rhythm for the stairs. Once the overall shape of the stairs is ready, I switch to the side view and draw a more precise profile for the steps. Since I drew it from the side view, the x-axis is a bit misaligned, so I use the set XYZ coordinates command to fix the line exactly on the desired axis. I extrude this profile to create a more accurate tread module. I then copy the steps for the number of treads required and place them in their designated locations. I repeat the same process for the landing and model that as well. After completing the stairs and landing, we move on to modelling the rails. First, I draw the main rail line from the plan, matching the slope of the stairs, just as you can see here. I do the same for the vertical rail lines. To model the rails, I use the pipe command, choosing a radius of 2.5 centimeters for the main rail and 1.5 centimeters for the vertical lines. Finally, by combining all the components, we have a complete and clean concrete stair model, including the wall, stairs, landing, and rails. This model is not only accurate in design, but also fully compliant with all safety standards and principles. Now that we've modeled the concrete stairs, it's time to model the same stairs in a metal form. The goal of this section is to introduce you to metal structure modeling and show you how you can use these techniques in your own projects. The first step is to set up the layers and units, just like we did with the previous method. This ensures everything is set up according to standards, making the work easier. As usual, we set the layers to centimeters. After this, I'll draw a base rectangle surface from the locked plan and lift it 18 centimeters using the gumball tool. Then, I'll copy this base rectangle for each step and landing, repeating the same process to build the overall stair structure. Follow the same steps as I do here. To make the management easier, I create a new layer called Base. Then, using the Change Object Layer command, I move all the parts to this new layer. This way, managing layers becomes much simpler. Now we move on to modeling the main beam and stair structure. First, using the base model we created, we draw a line that follows the slope of the stairs, just as shown in the image. Next, using the offset command, we add the thickness of the beam which in this case is 5 centimeters. We then connect these two lines using the loft command to create a profile. After that, we extrude this profile to a thickness of 10 centimeters using the extrude surface command to form the main structure. With the basic structure profile ready, we move on to modeling the details of the stairs. As I do, I draw another profile for the stairs and extrude it with more precision. To add more detail, I use the Boolean difference command to subtract the plate surfaces, making the details more realistic. Now that the main model is built, we proceed to copy this model for each step. We use the base model we created earlier and copy it for each step, placing them in their respective locations. Repeat the process exactly as I do. Next, we move on to connecting the stairs to the ground. I start by drawing a surface at the ground connection point and use this surface to cut the beams. I use the Boolean split command to make the cuts exactly as needed. For the cross-section size, I draw a rectangle and offset it by 5 centimeters from the same point. I then draw the bolt holes using circles. Once the cross-section is ready, I extrude it to a thickness of 9 millimeters. I copy the same cross-section for the other beam and place all the parts together. Finally, we have the complete metal stair model. This model includes all the metal components, such as beams, steps, landings, and plates, designed with great accuracy and high detail. If you found this video helpful and the content valuable, please show your support by liking and subscribing. This helps us produce better content and makes it easier for the channel to grow. Also, if you think this video could be useful for your friends or colleagues, please share it with them. I'd also like to take a moment to thank everyone who has supported the channel through Super Tanks. Your support means a lot to us and motivates us to continue providing high-quality, valuable educational content. Now that we've explored modelling standard and metal stairs, let's move on to modelling decorative stairs. These types of stairs are usually used in spaces that require beauty and unique design. In this section, we're going to model the same stairs we've already created, but this time with a more decorative form. In this tutorial, we'll dive into this category of stair design. As always, the first step is setting up the units and layers correctly. This ensures everything progresses accurately and to scale. We'll use the same settings as in the previous example. Using the locked plan, I'll draw a base rectangle and lift it by 18 centimeters using the gumball tool. I'll repeat this process for each step and landing to form the overall stair structure. Just like I'm doing here, you'll see how easily the overall structure takes shape. Just like in the previous example, we'll build the stair base following the same method. By doing this, we ensure that the stair structure is properly aligned and designed with consistency. Since this stair model involves connected plates, I'll draw a plate between each step and all the way down to the ground, just like I do in the video. I'll join these plates together to connect them into a continuous surface. To give the stairs a soft and elegant look, I use the fillet edge command to round the edges. This will give the final form of the stairs a smooth, decorative appearance. Finally, to add thickness to these plates and complete the stair form, I use the offset surface command. This gives the stairs their final shape and prepares them for the next steps. You can also apply different geometries and shapes to create more creative and unique forms. For instance, by slightly shifting the edges of the steps, you can achieve a more distinct and customized shape, as seen in this image. And that's it for modelling decorative stairs. These types of stairs can easily make a space more attractive and beautiful, while allowing for creative and unique forms to be added. Now that we're familiar with decorative stairs, let's move on to modelling spiral stairs. Spiral stairs are one of the types that are widely used in unique and modern spaces due to their attractive design. To create this model, we'll go through several steps, which I'll explain step by step. To begin, I draw a circle with a diameter of 10 centimeters, which represents the central column of the stairs. This circle marks the center of our spiral stair. Then I offset this circle by 150 centimeters to create the outer boundary of the spiral stairs. After drawing the circles, I draw a horizontal line from the center of the circle, which will later be used to create the stair lines. Now, using the array polar command, I replicate this horizontal line 12 times around the center of the circle. This ensures the stair lines are placed correctly in various angles around the circle's axis. Using the planar surface command, I convert the central circle into a surface. This surface will be used to model the stair treads. The boundary circle, which forms the column of the stairs, is extruded upwards using the extrude command to the desired height. Now, using the stair lines I created, I execute the split command to divide the floor surface of the stairs into separate pieces. Each tread is now separated from the others. I select all the stair treads and lift them by 18 centimeters using the gumball tool. To make the stair height uniform, I deselect one tread and then raise the remaining ones by the same height. I repeat this for each tread individually. To speed up the process, I create a loop and copy the stairs, following the same method to quickly generate the treads. After the treads are at the desired height, I add thickness to the floor surfaces using the extrude surface command. Here, I select a thickness of 5 centimeters for the treads. To add a handrail to the stairs, I first extrude the edges of the treads. Then, I draw a curved line along the shape of the stairs and split the extruded surface using the split command with this curved line. You can also do this in another way. To create the parapet edges, after extruding the edges, hold Ctrl and Shift to select them. Then use the gumball to move them slightly upward, just like I'm doing here. Now that we've completed all these steps, we have our spiral stair model. This model is unique and attractive, and you can use these techniques to design special and modern stairs for your own projects. In this video, I've tried to provide a basic and general tutorial on stair modeling. We started by discussing general standards, and then we went through a few simple examples to help you easily grasp basic stair modeling techniques. If you enjoyed this video and would like us to model more complex and advanced examples in future episodes, please let me know. This way, we can dive deeper and cover more specialized topics in upcoming videos. If you found this video helpful and enjoyable, please support the channel by liking, subscribing, and leaving a comment. These actions help us grow the channel and create better content for you. Thank you for being with me, and I hope these tutorials have been helpful for your projects. Until the next video, goodbye and good luck.